Alright, this is the first screencast for this session of lessons for Chapter 16, which focuses on integration. So in this particular screencast, we're going to be focusing on using the graph of the derivative to make predictions about the graph of the original function. So I'm going to give you a refresher, and then we're going to overlay the original function's graph to show you what I'm talking about. So if you'll recall, when the x values of our derivative have a y value of 0, those x values represent the x-intercepts of our derivative. So that means in this case we have an x value of -2 when y is 0, or when our function equals 0, and an x value of 1 when our function equals 0. When we have x-intercepts, those tell us that we are going to have we're going to have a maximum or minimum at those points in our original function. So we should expect, if I go ahead and put some vertical lines on here, we should expect a maximum or a minimum to be somewhere on this red line from our original function, and we should also expect a maximum or minimum to occur on this red vertical line here. And we're not sure where yet, okay? So the other thing that I know from this graph is when our y values are negative on our derivative, that means that my original function is decreasing. So the y values of that function are getting smaller, okay? When my y values are positive, from, when x is greater than -2 but less than 1, I know that my function is going to be increasing because the y values here are positive. Alright, so what I don't know though is my original function. When we integrate from a derivative, we don't know what that constant value is. So we know where there's going to be maxes and mins. Like we know they're going to reside on x equals -2 and x equals 1. We also know that we're going to definitely have a root where our maximum occurs on our derivative, right? But since we don't know that constant, we can't predict exactly where those values are going to be. So if I go ahead and put this graph on, what I know is what I said. The function decreases from -infinity until it reaches 2, at which point it has a stationary value, right? And we'll call that point B. So on this graph, because I had to put values in, we can kind of see that it looks like it's -6, but I don't know for sure what that constant is, so it could be something else, right? And then from B, point B, I'm increasing until I reach 1, okay, at which point I have another stationary point, which we'll call A. So we're increasing from B to A, and once I hit that stationary point, my slope there is 0, and then it starts decreasing. So my function decreases to positive infinity, basically, for x, and then for the range, it would go to -infinity. So the challenge here again is that if I don't know the constant, my graph could look like this. Or if I change the constant, because I don't know what it is, it could look like this. But notice that my minimum still is on x equals -2, and you can't really see this, so let me move this. It's still on x equals 1. My root is still occurring when x equals -half. But depending on what I change this constant to be, it changes where the graph is. So we know where the x values are going to be. Here's another example of how it can change based on what that constant is, right? You can see where the original one was, but if the constant was a different value, the minimum is a lot lower, and the minimum and the maximum are a lot lower. So, so the constant really affects the y coordinates of the min and the max. And yeah, so I think that is all that we are going to talk about for this lesson. So go to the next video to watch the next part of this first introduction to integration.